Thank you very much for joining us here in London. I was looking through your list of responsibilities in the at Qualcomm. So AI connectivity, processing, CPU, GPU, multimedia, peripherals, developer relations, infrastructure, data center. I mean, data center is a relatively new muscle, I guess, for Qualcomm to be developing, but you've got quite a broad remit here. I'd love to talk a little bit about how all of those things knit together. But first of all, the news of the week, I suppose, or last week, was that Qualcomm's making a new push into the data center with a couple of new products you're launching next year and the year after. Why could that possibly be of interest right now?
All right, that's an excellent question, by the way, and maybe I'll unpack the first part of your observation. As Qualcomm, we have a pretty broad product portfolio that goes everything from literally from doorbells to data centers. And that's a pretty massive portfolio. So if you kind of think about doorbells and smartphones and PCs, XR, consumer and industrial IoT, wearables, and automotive, there's a lot of connectivity, compute, multimedia processing, and software that goes into all of these products. And so if I could kind of really focus on, why now for data center, and maybe I'll try to give a little bit of a background as to why we thought that this is the right time for us to enter the market. First, full disclosure, this is not the first time that we've tried it. It's actually, arguably it's about approximately the third time. But one of the things that we've been doing over the past 5 years internally inside Qualcomm before actually revealing our plans is to build our strength in high performance, energy efficient computing. We feel that it's absolutely critical to scaling first on devices, but also increasingly in data centers. So as we built up our capabilities with our custom processors, both for CPU, for general purpose compute, and as an AI head node in data centers, and our NPU processing, which is specifically meant for AI inference, and it's kind of designed from ground up on that. We learned a lot of lessons in smartphones, in PCs, in automotive, and in industrial IoT. And in that sense, around maybe I would say 18 months back or so, we felt like we now have a pretty strong portfolio in that space. But more importantly, the processors are battle hardened. The software has been exposed to so many different developers that are out there. We felt that we could put it all together and offer some compelling solutions and innovative solutions in data center. So in data center, the two products that we announced, and the product announcements was followed immediately by one of the customer announcements with Humane that we did. The product announcements are focused on rack level solutions. So moving forwards, what we are offering is not SoCs, but really it's cards, servers, and racks, which provide very compelling performance per watt, TCOs in terms of the performance per dollar that we bring in, which we think is going to change the way that we'll start thinking about data centers. Energy efficiency is key, so we spent a lot of time on that. And the other part that we brought in is we've also been spending some time on addressing the other part of AI. Historically, a lot of the focus on AI processing has been based upon the compute capability. You keep increasing the computational horsepower on your processors, and you get tremendous amount of performance increase as we go forwards. But we also felt that it was important to pay attention to the memory architecture, because you do have a lot of data that's moving back and forth all the time. And sometimes that happens to be the bottleneck. You always have to balance between compute and memory. So we spent some time on that. And in the second generation of the products, the AI 250 that we announced, we're bringing in a new memory architecture, which we feel actually takes it up a notch further. And this was the gist of the announcement that was made. But why now? We felt that we needed to learn our lessons first in other domains without just directly jumping in. There's lots of incumbents out there that they have their very strong presence. So when we enter the market, we wanted to make sure that we have all the right tools and the right products to be able to compete.
And so just to unpack a little bit about what you were saying around, normally Qualcomm makes SoCs, system on chips, which are just a much smaller package, but this time you're selling the whole rack, that goes into a server, right? So why is that the architecture that you need to move to, and how do you package that? Why is that important for this particular AI use case?
At the end of the day, it's not just for data centers, but starting even from enterprise servers all the way up as you kind of move into the network. The SoCs are only one portion of the equation. At the end of the day, it's actually a system of chips that have to be put together, and which also meant that we wanted to provide like a more complete solution as opposed to having someone assemble all of this together and do that. There's a lot of hyperscalers who actually do that. That's perfectly fine. But the complete solution does help in terms of a turnkey deployment. And one of the parts that we did along with, our own processing capability is uh, earlier this year, and we are well underway in terms of closing the transaction. We went with an acquisition of acquiring some additional assets in the networking space
This
with
was
Alpha.
AlphaWave.
This is Alpha Wave, that's correct. And that actually complements everything that we have on compute and software. We actually get all the necessary assets that come in from them. Today, we license that IP, but tomorrow, as we have the networking components, we feel that we have like a complete solution to be able to put this together.
And so, how do you? I mean, if you're, where is this? Who is the target customer for this product? Is this aiming for the hyperscaler clouds, or is this a different type of customer?
We have two different kinds of customers over here, and maybe more depending upon how we count it. But broadly speaking, we have cloud service providers who are interested in a complete turnkey solution. So as in just ship the rack, I have the whole software enabled along with it, and then you actually go ahead and deploy from there. So that's like one category of customers. But at the same time, we are also working closely with some of the hyperscalers on they have their own in-house solutions. They build their own racks. We don't see any problem in saying, okay, there are some specific unique elements that we have, our processors, some additional things that we bring in, maybe our memory architecture, but there's a bunch of topics that they can actually pick up on and say, okay, I would like the following solutions from you. In that instance, it's slightly different. It's not the rack. It's not even the server for that matter, but it's actually all the way down to SoC level, and maybe at a memory level, it's slightly different. So we do have these two different categories of products, but our focus is on everything from scaling up from SoCs all the way up towards racks.
And so, how do you surmount NVIDIA's CUDA moat, the software stack that they've built over 10 plus years that's really locked a lot of people into their ecosystem to date?
So the way that I see it is that NVIDIA has done a phenomenal job in terms of building up their products. I mean, kudos to them on that one. What we are trying to do is bring in an additional level of innovation and two other vectors of differentiation. I talked about the memory architecture, and maybe it's a good time for me to spend a couple of minutes on that. We've always had this sort of a two-pronged approach in the industry so far when it comes to memory. On one hand, in devices, you kind of focus on what's called as the LPDDR family. It's low power. It's really meant for, it's what we use in our smartphones. It's what we use in our PCs. Power is everything. So it's extremely low power consumption, but the bandwidth happens to be very low, and therefore, it has its own limitations. Meanwhile, in data centers, we have HPM, which is extremely high bandwidth, but the power consumption is much higher. And so we wanted to bring in like a best of both worlds, try to blend both of that together. And that is something new. We feel that it will have legs as we go forwards, and we'll see how that plays into the market. So that's like one vector of differentiation. The other one is the processors themselves, and it's kind of important to kind of step back a little bit on that. Increasingly, there is a demand for energy efficient and high performance, both energy efficient and high performance computing in data centers. It's no longer about just raw high performance, but also have a leash on the overall power consumption that occurs in the data centers. And we see that in several markets these days. And our processors were built specifically for energy efficiency. So it was kind of natural for us to then only focus on the performance side as we go into data centers, but we still have that heritage of energy efficiency. So it's a natural step forward for us. And that's
Energy
the second.
efficiency because originally they were built for the phone and you were battery
That's
constrained
correct.
for
Yeah,
them. Yeah.
that's correct.
But I guess the reason I was asking about CUDA was just more on the software side. How do you? I mean, that's the hardware is only one part of the puzzle here. How do you get developers building on your platform, and how does the fact that you've had developers building on other devices, smartphones, doorbells, help with that?
So a couple of points over there. From our perspective, what we have done is we have a software stack which we built up first for devices, but we kind of leveraged that and optimized it much further for data center in the following way. Pick any framework you want, pick any runtime. We'll provide you all the tools, the debuggers, the profilers, the compilers, and pick any operating system. But one thing that we have done in data center is we've also kept it open. So in other words, it's a totally open platform. We provide our own transformer libraries. You go to something like Hugging Face. There's more than 2 million models over there, making it easy for developers to come and pick a model from there and then run some applications on top. But I'll be honest on this one. I think it's a journey for us. We've kind of made a lot of inroads with that. But I would argue that we still have ways to go as we kind of, make the software more mature. But here's the best part of it. We're not alone in this journey. We don't have to necessarily provide everything that's needed on software. As we work with our cloud service provider partners or hyperscalers, they have their own software. So it actually is them cherry picking what they need from us and then adding their own software on top of it. So it's not like we need the complete solution from us. There is some additional software that comes in from our partners. Yeah, it's definitely.
I was just saying we've seen OpenAI do a lot of silicon deals lately with NVIDIA, AMD, Broadcom. Are you talking to them? Are you talking to Mr.
We are
Altman?
talking to all the hyperscalers, and I'll leave it at that for now.
All right. How do you see AI, just to sort of shift back to your core business, as it were? How do you see AI changing the smartphone in the coming years, and why has that taken a little longer, particularly for some players, to wrap their head around than maybe we would have thought when ChatGPT came out 3 years ago?
That's a very important question, and maybe it'll be helpful to kind of provide the right context to that because it's broader than smartphones, but I'll also talk about smartphones over here. One of the things is that if you kind of go back in history, and not that I've been around since that long, but 60s and 70s, it was all about command line interface. You had this gigantic screen and then a green interface to it, and you just type in everything on command line. And that was the interface that we had for the longest period of time. That changed in the 80s with the introduction of the mouse, the graphical user interface, and for the longest period of time, that was the mainstream thing. 20 years later, then we moved to in the mid 2000s with the birth of the smartphone. We moved to touch, and touchscreen became the natural interface for us. And it's about 20 years since then, and not that I'm predicting that every 20 years there's a change, but there's clearly a lot that's happening behind the scenes. What is the new UI, the user interface that goes into all the devices around us? Now, the smartphone is an extremely mature product at this point in time. But we do see that it is a place where the next evolution of the smartphone actually is, even today, we all have a clutter of apps on our phone and you kind of have to scroll down and click and so on. Each app resides in its own silo. You don't have one app talking to the other app. You have to do the work. But the agentic AI processing, as it permeates smartphones, we do see that UI changing quite a bit. I would like to talk to my phone a lot more often than actually picking it up and trying to scroll through things, especially if I'm wearing my earbuds. So there is a gradual evolution. I don't think this is just a prediction, but smartphones, there's no like immediate revolution that's occurring wherein you jettison everything that we have and pick up something new. There is an evolution that's occurring over there. But at the same time, new kinds of devices will appear in the market, which actually start off the bat with a brand new UI. We see that, by the way, in XR, in AR glasses, where actually you don't have the luxury of using your hands to, well, you can still move a few things here and there, but you can't actually touch anything. But what you end up doing is using your voice as the UI, and you can actually see what you can in front of your eyes on the glasses. So AI is, we have gone out and said AI is the new UI. It is the way that actually we're going to be interfacing with things moving forwards. But in some instances, it's going to be a gradual evolution That's what we expect in smartphones. Whereas it's going to be a brand new device category that we will start seeing as we move forwards in other cases.
I know Qualcomm has perhaps a slightly checkered relationship with Apple, but why do you think they've taken longer to figure out the new Siri than even they had thought? I mean, it's always interesting to see how disruption plays out in the marketplace, but clearly they felt like that wasn't ready for prime time. They've delayed it. They've said that it's coming next year. But like, why was a startup able to come up and reinvent that experience and an incumbent wasn't?
It's a good question. Probably best for Apple to answer that, not for me. It's hard for me to speculate on that. I mean, we are focused on what we need to do, but yeah, it's a good question for them.
But I guess more broadly, you've been talking. I mean, I interviewed Cristiano, your CEO, a couple of years ago, and he was talking about the sort of AI as the new UI. Then I still feel like I'm waiting, whether it's Apple or anybody else, to really kind of see it show up on the screen. I mean, do you think it needs a whole new device? Do you think it needs some of these AI wearables, whether it's the Meta Ray-Bans or whatever Johnny Ive's cooking up with Sam Altman at I/O, like to kind of move things forward here? Do people want their phones to change?
I can give a little bit of a perspective on that. So clearly, but you mentioned the AR glasses. The AR glasses are taking a life of their own, and we are totally excited about how that trajectory is playing itself out. So that's like a brand new device. I mean, today we have devices which are still tethered to your smartphone, if you kind of think about it. And as you kind of move forwards, you should expect to see devices which are like directly connected to the network at a point where now you have direct connectivity as well. But there is something else, and this is related to, you asked the question, why are smartphones taking a little longer? I want to actually talk a little bit about hybrid AI over there. One of the challenges that usually comes up is when you want to run some use case which requires some sort of a large model, you always have the question of, do I want to run it on the device or do I want to run it on the cloud? The natural answer is, if I have excellent connectivity, by all means, run it on the cloud. I mean, there's no reason for you to run it on the device, on a smartphone. But there are some new attributes that come in on a smartphone, which is hyper personalization. This is local context information. You don't want to send everything that you have out there. So there is some benefits of actually running it directly on the smartphone. But if you want to run it just on the smartphone alone, you have to then blend in the combination of what you want to run on the cloud and what you want to run on the smartphone. So it was natural to see that, yes, we do see use cases today in smartphones, but they're all very focused on, I would call them as like more multimedia processing. Every time you edit a picture, every time just for fun, you want to change the background behind you. All of that uses state-of-the-art generative AI. I mean, these are not like these are pretty sophisticated models. Distillation. These are a lot of the models that are actually used specifically for image editing, and so that's actually come along very nicely. However, in terms of the voice UI itself, I still feel that it's a bit of a journey. And but we're not that far from seeing us use voice as a more natural UI. It has taken time just because of the fact that there's a lot of legacy. There's like so many apps and so much of software that's written over there. It's a more slow moving train compared to what we've seen in some of the other markets.
Okay. We only have about 30 seconds left on the counter that I can see that you probably can't. But I just kind of wonder about how, given you talk about that, the potential for these devices. I mean, do you see a big new market in AI wearables and a whole new category emerging in the near term, or is that still going to be another 5 years away, like VR headsets were, or the sort of longer? Nothing supplanted the smartphone. Yeah.
I feel like we are at a point where we do see a universe of devices around a central hub based upon which the evolution will occur. And no, it's not that far off. We already do that today, but the combination of all the devices around us, there is a universe that we can actually build along. And keep in mind that these devices eventually interface in the cloud, and that's where the hybrid AI concept becomes equally important. You have your earbuds and something more maybe, but the combination of earbuds, wearables, a phone, a PC, and then something in the cloud. These are like kind of table stakes, but now we are introducing glasses.
Okay. We'll have to leave it there. Durga, thank you very much indeed.
Thanks for having me.